I didn't understand why the bubble would start back up after it collapsed. But here's what's going on. There's an equation called the Rayleigh-Plesset equation that describes everything a bubble does underwater. It's too hard to solve by hand, you gotta use computers to figure it out, but this is basically what's going on. At the initiation point, you have a super high pressure inside of a bubble and it begins to impart momentum to the fluid around it, so it begins to grow. At some point, it passes the point where the pressure inside the bubble is equal to the pressure outside the bubble, and it continues to grow until eventually the water stops it. Now at this point, you have low pressure inside and high pressure outside, so it begins to collapse again, and because of fluid momentum, it goes again beyond that equilibrium point and begins to compress. So it gets a super high pressure on the inside again, and boom, another shock wave, and the process starts all over again. This oscillation occurs until you dissipate all the kinetic energy in the system. Sonoluminescence occurs when you get a flash of light when a cavitation bubble is collapsing. Now, as much as I want to believe this is sonoluminescence, I'm pretty sure it's just a really cool reflection from the sunlight above the pool. But it's still really interesting that it occurs at the point of collapse. You're not just shooting a bullet out of this gun, you're shooting three different things. Now that we understand the physics behind cavitation, you can clearly see the effects of each of these three components in the high-speed video.